Okay, good morning everyone. This is the Dash High Availability meeting on September 20th, 2022. Today's main agenda item is AMD Pensando's presenting their HA proposal, and we have been reviewing the SI APIs portion of it. So we'd like to continue that today, and Sanjay will be presenting that from AMD Pensando. If possible, after this presentation, maybe Guhan and Prince could also talk about the HA design with overlay ECMP. Before we start, any questions from the previous meetings that anyone may have? Okay, please continue, Sanjay. If you can please share your screen.
Yeah, give me 1 minute. I think I'm having some trouble. It's asking me to update something when I'm trying to share.
Okay, sure.
Yeah. Do you want to go with the other part of the agenda? Then we can come back to this if it's, or I'll just give it a shot. If it happens in a couple of seconds, it's fine. Otherwise, I'll.
Yeah, that sounds good. Maybe you can try for a little bit. Let me check if Guhan has joined.
Okay.
Yeah, so Sanjay, I can present the screen for you as well if you think that's okay. Or yeah, I just noticed that Prince also joined. Prince, we were thinking that, at the end of Sanjay's presentation, maybe you want to talk a little bit about the overlay CMP, how it, we foresee it working with HA design that Gohan had brought up.
Yeah.
Thank you, Prince.
Yeah, I think, Reshma, if you could share, kindly share, I think the last couple of pages, we can just
Sure.
go through them. I think it's the last two.
Okay, you can
Flow
see the
diagrams.
screen?
Yeah,
Okay.
yeah.
Please let me know when I should stop scrolling.
Yeah, I think it's the last. I think we had done the node pairing last time. I think we just stopped before the stateful and the switchover pieces. Towards the last two pages, Reshma.
Okay.
Yeah, we just completed. Yeah, even below.
Oh,
More. Yeah, we just finished this last week, the node pairing sequence.
sure. Okay,
And I think we had the unplanned switchover and the planned switchover.
got it.
Yeah. So in the unplanned switchover, I think here what we are, this is still the heartbeat being managed by the data path CPU. In this case, what the proposed flow is, the loss of heartbeat is detected by the DPU, and it updates the SI SDK about the status change. Right, I think the first part of the status change is mostly to keep for debugging, but to keep the state machine in sync so that all current state is reflected properly. And after that, the switchover is initialized on the DPU data path to switch over to standalone, right? And once the switchover is complete, the data path again notifies the DPU again notifies the Sonic state machine that switchover to standalone is complete. And then the Sonic side, the Sonic stack, can, I think I think currently in the current implementation of whatever you have done, so the controller determines that after switchover, all the configs have been pushed, right, is up to date on the new standalone, that is the old standby. This being, I think we touched upon this sometime in one of the previous meetings too. Both the nodes the active and the primary and the secondary, they may not be in exactly the same at any given point in time. The two might be out of not in sync with respect to configuration, because the configuration is done independently by the controller on both sides, right? I think we had touched upon this with respect to the policy state, the policy results being communicated, being passed across from the active to the standby, so that the standby does not reevaluate its policies, because the policies may not be the same as what the active has. So that transfers here too. So when the switchover happened, there are flows that are there in the new active DPU, which has policies evaluated as per the policy that was there on the erstwhile active, right? So we want the policy to come back to the same state on the new primary before we kind of re-evaluate all the flows or do any, clean up the flows or anything. So hence there is the controller has control. The controller today issues an API which says flow reconcile. At this point in time, I think the notion is the controller knows that whatever is the current state of config has all been pushed to this node. And once this is done, there is some flow reconciliation that happens. So all the current flows are reevaluated um, based on, to see if it matches the current policy. If not, it is updated. So that is the unplanned switchover. Similarly, there is a, can go down. Thank you. So there is a planned switchover. Uh, yeah, in the planned switchover case, yeah, so there is here, I think there in the unplanned switchover, there is possibility that there can be some little bit, I mean, some traffic drop when the network is reacting to the change. There might be some traffic that is black hole because it's still going towards the old active, etc. So with the planned switchover, the intent is we try to keep for that any disruption in this thing as close to zero as possible, right? So this is because we have the flexibility here to coordinate the switchover between the primary and the secondary, right? So when there is so the controller comes and says switch to primary, I mean there is a trigger that is given to say that we want to switch over. When we want to switch over, the DPU data path on the other side does some primary function to, I mean, to prep for switchover. And on the old active side, we withdraw the protocol route. For example, if it is BGP, we withdraw the BGP route and then wait for a convergence timeout, right? Once this convergence timeout is there, it says switch to standalone. When the switch to standalone notification is sent to the new old secondary or the new standalone that we want to. So in this case, there is a state called as a pre-standalone. So we let it soak in. There is a small timeout that we have. And once that is there, once that is done, the standby side switches over to standalone and then notifies the active that the old active that it is switchover ready or it is switchover is done. At which point the old active can actually shut down. We can close the communication channel and actually exit. It can shut down. After this, again, if you notice on the lower part of this thing, again, the whatever we had to do with the flow reconcile, the same sequence follows on the new standalone again. So this is the sequence where, in this case, what happens is because we have kept the active functional, even when the standby had taken over as the standalone till everything was complete on the standalone side. If the network were to redirect any traffic because of uh, due to no, we were in the transient phase of route convergence in the network. If it were to land on the active would still forward the traffic, right? So hence there is no loss in any drop in any traffic throughout the whole sequence. right? So that's the thing.
Sorry, can you expand one more again? You're saying for the unplanned switchover, there is no um, zero drops, right? So
For planned switchover, we can do zero drop Gohan, but not for unplanned switchover. For
yeah, no,
example,
no, I get that part. It was why the planned switchover is no drop at all.
uh, so uh, usually the drop that we see is, for example, when the active goes down, there is some reaction time. For example, if you're doing BGP and we are doing the BGP advertisement going for the from the active. So it takes some time for the network to react to that BGP advertisement so that it can take off, redirect all the traffic. It can choose the secondary path and send it towards the surviving node in unplanned switchover. So that causes the drops that we know of, right? Whatever drops we see in this thing. So this is for the rest of the the fabric to react to the failure. With planned switchover, we can, because we have the active still running, we leave the active running, so that even we try to, that window where the network is still converging, we try to keep the active running. So even the stray traffic that the network might redirect to the active, we are still able to forward it, and hence we achieve zero loss with the planned switchover, but not for the unplanned. Does that
But
make sense, Kwan?
there is a little bit coordination, right? For example, in the planned one,
Mhm.
when do you direct? For example, if you direct the traffic, um, because on the data plan there is a behavior change, right? So active one no need to send the same to the to the standby one, right? So but if we switch a role, there is a change of role. So now the new active one should send the traffic to the new backup, right? So I'm just trying to,
Oh, I see. Yeah.
because
So I
there's a
think
little bit unsynchronized events that could cause, for example, let's say, you ask the BGP to redirect your traffic to the new active. Now, the new active will start receiving traffic. You send the same to the to the previous active one, right? So, but what if you know what if you switch the what if you make the previous active to standby, and then at that moment you still receive the traffic from the network? What does that do, right? So there need to be
correct.
you know perfect synchronization between the data plan and the control plan to inject the traffic, right? So have we analyzed those?
Yes, yes. So I think maybe I think I understood your this thing. If it's not, please correct. So I think the what happens is in this case, right, when there is a planned switchover, this is usually, I think the cases that we this thing is for there is some maintenance on the other side, right? So we want to drain all the traffic from the current primary to the standby so that the current primary, the old primary can be brought down and there can be maintenance done. So what
Mm-hmm.
we see in the state, whatever in the flow is half of it, right? So we have come till a state where the primary can be brought down, right? Once the primary is brought down, the whole node pairing sequence starts again. So it is like it's gone down to standalone. In standalone, we are not syncing any state to the other peer at all because it's not active, right? I mean, it's not even paired up. After that, the old primary goes down, reboots, comes back up, and once it comes back up, it starts the peering session again, and
Oh, no,
which then
no, no.
follows
Okay,
the
but sorry,
previous.
but when you brought down the old primary at that moment, do we expect any package drops? How do you brought down that old primary?
So Reshma, could you just go down to the plan switchover? So here, Govan, if you see that on the in the middle section, we actually de-advertise, we withdraw the routes, BGP routes on the left side. If you see towards the middle, right, we withdraw the routes. So at this point, we have already signaled to the network that we no longer can handle traffic. And there is a configurable timeout which we allow the network to react to that advertisement and stop forwarding any traffic to the old old primary. So this is the time where the traffic is drained. Any traffic in flight is drained out. So during this timeout, we can receive traffic on the active side too, and the active will continue to forward because we haven't brought down the uh, forwarding. I mean the forwarding the data plane yet. Right after this,
Also,
yeah.
so also
Yeah.
during this window, both both DPUs can receive traffic. It's kind of like both are active.
So when you start training the traffic, right? So you're active still the forwarding traffic, meaning that it will send the traffic to the standby, right? So, or it will what it will do at
The
that
flow
point in
sync.
time.
Flow
Yeah.
sync. Yeah, yeah. So if there are new flows that we receive, we will still sync it to the standby during this timeout.
Okay. So when you're training the traffic at that point in time, what is the standby state? What if the traffic directly go to the standby? What will standby do?
So there is um, so this is this window where I think there is some amount of reconciliation that's happening. So the standby is also, for example, if there are new flows that are getting created during this small window, the standby is also,
No,
I
I'm not
mean,
talking about I'm not talking about the flow state. I'm just talking about
for the
for
traffic
example,
itself.
you're training traffic. You say, okay, maybe I need the 1 second or 3 seconds to drain the traffic from my active.
Networks.
But at that point, maybe at that point, if the network is being able to train quickly, then you will send the traffic to the standby, right? So at
Yeah.
that point, what will standby do when it receives those traffic?
The standby will also forward go on. It is forwarding.
Forwarding to what? Forwarding
Uh,
to the VM directly or forwarding to whom?
to the VM directly. So it is doing regular forwarding for the flow based on the flow, the flow data that was synced from previous when it was standby, right? Whatever was there, it will use the same flow data and keep forwarding.
No,
The
but
data
what
plane
if
data
new
plane is active.
connection? What about new connection?
So new connections are also created on the standalone on the in the pre-standalone state or in the left side. We are still creating new connections on both sides at this point. So there is a reconciliation that's happening on the uh, admin standby and the admin active, which can both be receiving traffic in this transitionary state. Both of them are creating flows. There is a two-way sync that's happening.
Is that somehow capturing the spec? I'm not sure. Previously we talked about that. For example, if one of them active, one of standby, if the standby receive any traffic directly from the network, not from the active, will it create those flows, or will it not create those? Will it reject the flow? Have we make that clear in the spec? Or I thought it was standby should not receive any new flows when it's in standby state directly from the network, and if we receive,
That
it should reject, right? So, or it should create the state.
Yeah, so I think we have mentioned that, and I think here there is one, maybe we can, if it's not sufficient, we can expand. In this section also towards the end, it is mentioned that during this window, both the standby and the, uh, yeah, I think during this network, the last line that is in the shared portion. Yeah.
So Sanjay, I have a question. So in that particular time, the state of standby is different than
Mhm.
what it is during, before the plan switchover has begun, right?
Right.
So what is that state called?
I think it's called pre standalone.
No, let
It's
me,
yeah,
Sanjay, let me try to
go ahead.
explain. Yeah. So
Yeah.
basically the stable state is active standby. Okay. So the standby will drop the packets whenever it is the role says standby. It will never forward packets. So during planned switchover, there is a role transition that is happening. It is not like standby will go to standalone right away, or it will remain in standalone. So what happens is this. So say stable state of active standby, and the controller will say, so let's say we decide to do planned switchover where we want to take the active side for maintenance. So we will go and issue switchover API to the active. So then active, what it will do is it has to now do a switchover towards the standby, right? So first it will send the switchover event from the active side to the standby. So that's the topmost line that you see there, switch to primary, whatever, right? So basically it will go to the standby. The standby will become active because there is a switchover event that is going on where it is going to take over and eventually going to become a standalone. So first it will become active. That means it is basically it is setting up itself to switch traffic. So it will become active. It won't receive traffic yet because the left side is still as its route advertised with a better path, right? Better ASN. So the right side becomes active, gets itself set up for switching traffic, and it will be there in active. So at this moment, both will be active. Then the
hold on. I mean, this part I have a question, right? So if you're saying at this very moment the standby becomes active, then what about if the previous active still receiving the traffic and will send the traffic to the standby syncs, right? So or the previous active will stop sending the encapsulate the SIM packet and send to the standby.
Yeah, so the sync will all happen the same thing. So active is like active can send
I'm asking a question that what is the previous active behavior in terms of receiving a SIM packet?
It is continuing to send it to the peer one.
So active will still continue.
Okay. Sorry. Okay. So if it's sending the SIM packet to the new active, and then is that expectation the new active? What is the expectation of this new active do with this SIM packet received from the previous active?
It will sync that. It will take the sync and it will create the state. So basically, it's like full
okay,
active.
No, hold on.
Why will it do?
Are you saying that when device in active state, it will always, whenever you receive a encapsulated SIM packet, always create a state?
If the role is in active state, if it gets the flow sync, it will create state. Is that your question? Sorry, I didn't catch it.
Yeah, that's no. I thought the active should not receive. Okay, so
yeah, active will never receive.
Active one. Okay, so I think that's maybe not defining a spec. You're saying that even if the DPU's role is active, whenever you receive an encapsulated SIM packet, it will replicate the state.
Right. So see, normally it is in active standby, so it won't receive flow sync request. But during this window of planned switchover, there is a small window where they will act as active in order to take care of the traffic that is coming on both sides, right? So yeah, so that is the duration during which it will operate in that manner.
No, but I guess Hanif's question was that do we introduce because each device only know its own state, either active or standby, doesn't know this combined active state, right? So therefore, are we going to introduce a new state, for this internal?
Yeah, go ahead. There is no state. Yes, you are right. Active will process any flow sync request coming towards it. That's how it is designed. But in the stable state where whenever it is active standby, it won't receive flow sync requests because standby won't send flow sync requests.
Okay. That is actually, yeah, if we say that in active, so let's say for a time being, if you're a true active, before they, and if they stand by for some reason, receives the traffic and then sends you something, right? So you will still send, take that flow.
Standby will drop the packets. If at all it is in role standby, it will never take the packets.
Yeah, not create the flow and send it. Yeah.
No, but my question is that in when you are in this, let's say in a true state, right? When you are active and there is a standby, So I'm coming back to the same thing as Guhan is saying, that there has to be a new state that is defined where it says that, okay, you are willing to take a flow sync, although you are in the active state, right? And you are willing to even send out the flow sync when you are in the active state. So this is somehow there is some sort of a discrepancy that I see when somebody gets into some state. There is some things overlapping, right? There is functionality has to be very clear cut as to what state means what, right? What is your role as per what state, right? So
No,
somehow
see the
there's
behavior. See the behavior is in case of active standby, strict active standby, yes, active won't receive any flow sync request, right? The active standby behavior is becoming a active behavior during this planned switchover case. That's why it is taking the flow sync request and it is handling it. Yes, you are right. See that the active doesn't know whether the other guy is standby or not. So anytime it gets flow sync request, yes, it will process it. But the idea is that, I mean, see, it's in the stable state, it is going to be active standby. Like, I mean, basically based on whatever pairing mechanism we can, we ensure that they are in active standby and things like that. And standby is, expected. I mean, standby, we drop packets. We don't set up the connections or anything like that, which is resulting in, flow sync requests going towards the active.
So in other words, the thing is, on the active side as rules, right? As this thing we can say on the active side, we always forward traffic, and any new traffic that is coming, we will sync that new state to the peer, right? That is the active states. This thing. At the same time, when in the active state, currently, if there is a flow sync packet that comes from the peer, we still process it and insert the flow. That is the active state. On the standby state,
yeah. Please continue.
Yeah, on the standby, if we are in the standby state, for any traffic that comes in, we will drop the traffic if it reaches on the standby. So those are the rules. I think this thing is so with these two rules, what happens is the active receiving flow sync packets from the peer only happens during that window.
I didn't quite capture the rule on the standby. What is the standby rule? Can you say it again?
Yeah, on the standby. Sure. On the standby, any traffic that is coming in to be forwarded is always dropped, but we will receive any flow sync packet that is coming in and create the state on the standby.
Okay. Okay.
So one thing I don't
With this condition, the only window where we can receive flow sync packets when we are in active state is this transitionary state. Yeah, I think for debugging or for more this thing, we could have created a new state, but effectively this active where we are actually inactive and also receiving flow sync packet from the peer, it only happens practically only in this small window, right? If you want to capture it better for debugging, we have
if we have this transient state where we are actually working as active, and there is no really problem with that, why do we need to have an explicit standby state that I assume needs to be switched to active by the control plane? What is the benefit of having a standby state as opposed to just working in active all the time?
Yeah, so full active requires even more a lot other support to be handled. So first of all, if it is active, forward flow can come to one side, reverse flow can go to other side, and there can be it is tough to track the sequence numbers, state tracking, and there can be flow shift that can happen dynamically. Like a lot more things to be taken care of.
No, yes, I'm not saying that we will have two directions going to different devices. I'm just saying that any one of them is ready to learn and sync a new flow.
No. If you say active, automatically traffic can come to any one of them. The forward flow can come to one of them, reverse flow can go to other one.
I don't really agree with that. You're saying you will have the transient state for some time. You don't expect one direction going in one way, for the same flow, and then the opposite direction going to the second device, you expect that there will be a point in time where packets that belong to the same flow will go from one device to the other.
Packet for the same flow will go only on one device. But what I'm saying is forward flow and reverse flow, right? See, in full-fledged active, what is going to happen is both devices are going to advertise the virtual IP with the same cost, right?
In steady state, it can keep switching between the two.
No, I'm just saying
active would be ECMP. Here, I think
keeping a secondary device in active role means that it is ready to take over at any time without explicit notification.
No, so the active, see, there are all those active challenges will come into place during this short period as well. But there is a reconciliation happen because we know the fact that it is going to switch over towards the standalone, and we will reconcile some of the things. So basically, yeah, there is a short period where it will become active, but if you have to be active in a stable state, then you have to take up even more other things, like as I was saying, the sequence number tracking, the state change, there will be dynamic flow shift from one side to another side, so all those challenges will come.
Yeah, I agree with Baki. I think active is a much more complicated state machine, right? But Baki, my question is, in this case, why do you, so the standalone, I think it is switching to an active state a little too early, Why can't it stay until, when it really becomes active and can actually start forwarding the traffic? Until that point, why can't it stay in the standalone?
No, we don't know when the other side is going to withdraw. I mean, we want to control it, right? Coordinate, right? In the sense, before you withdraw the route from the existing active, because as soon as it withdraw, the network can anytime steer the traffic towards the new one. So in order to coordinate that, the node that is going to withdraw first tells the other node, you go active, prepare yourself to receive traffic. So that way we don't miss anything, because if you don't do that, then it will still be in standby. And if at all traffic gets steered towards that standby, will start dropping the packets.
Yeah, so once we withdraw the route on this thing, right, on the old primary side, there we don't know when traffic might start hitting the standby, right, from the network. So that is why it moves to that just before we withdraw the route. We prep by going to active state, so that once the route is withdrawn on the primary side, on the left side, we are ready to forward traffic on the right.
Understood. Okay. Yes.
So Sanjay and Balki, in each card in the HA pair only has half of those flows that it is active role, that it has active role on, right? So I'm wondering, when we are in that active mode or whatever, right? And we get the sync message when we process it, are we going to check that, okay, this is the flow that I am the active, have the primary role for? And if that is not the case, that's only when we will basically add it to the flow table.
Yeah, the role is maintained at the per virtual IP level, and there is FSM running at the per virtual IP level. So basically, for the virtual IP for which it is active, the FSM will run in such a way that it will tell the peer to go to active because the peer is standby. And for the FSM where the local is standby, the peer is already active. So there is that particular transition is not there.
Right. So then each time we get the sync message, will we know that, that's the VIP that we should be adding the flows for, or we are already active, and is there a check of that sort?
Sorry, what check? I didn't get that.
If we get a sync message, that has some flows that is being received by the previous active that was paired, right? Anytime we get the flow sync message, do we check whether we are the active for that flow or standby for that flow and then add it to the flow table, or there is no such a check?
There is, see, everything is tied to whatever the ENI and as well as the virtual IP, right? Because ultimately all the flows have to be tied to some FSM. Because the FSM is basically running at the per virtual IP level, and it will address only those flows that are associated for that virtual IP.
Okay.
So I remember, for the active, you also need to send the sync message to the other side, right? So when you made the standby to be active, does it also send those sync message to the previous active, or because it's not paired, so it doesn't send that message? During the switchover time.
So go on, if I understand it right, I know I'm not answering for Aki, but I want to understand your question first, right? So when in this, the moment it turns active, that doesn't mean it would immediately start receiving traffic, right? The better ASN prefix need to be advertised and the other guy should withdraw it. Only after that it would start receiving, right? So I understand there is no explicit shake hand between these two endpoints to, connect the dots between when somebody is not becoming active and this guy can become active, but the flow of traffic would never be duplicated, right? So when my understanding is that
that part I'm not sure, right? So because there is no exactly time guarantee that when the prefix will be rejoined, the switch to the new active, right? Because that's the reason, I guess, they will want to make the standby to be new active first, so ready to take the traffic, and then do the prefix restore. Therefore, you basically have a backup, and whenever the traffic start landing to the new active would send the packets to the VM, right? So, but my question is that, okay, I understand that part now, but the question is, for the new active, does it also send the flow sync to the previous active at this moment, or no?
So that's
Yes.
what. So there, yeah. Go ahead, Sanjay. Sorry.
Go on, Balki.
Yeah, the active. See, active. The role active is like the regular active role, where it will do flow sync request with the other side as well. So during the active, yeah, flow sync can go either way depending on how the kind of packets are landing. But then later it will. There is a newer state, right? As you see in the picture, there is something called a pre-standalone. So when it gets into that pre-standalone state, that is the state which it will get into after the address has been withdrawn from the old node, and also there is a convergence time period after which there is that in the pre-standalone state. It won't do any flow sync towards the other side, because it is pretty much at that point determined that the other side is going to go down. So it won't do any flow sync requests towards the old node, but whatever that is coming from the old node, it will be taken. So it is a different kind of role, not a kind of standalone role. It will take whatever that is coming, in the form of flow sync response, whatever that flow sync request, whatever that was sent sometime back, there can be flow sync response coming back. So those things it can take, but it doesn't send any flow. This new node, which is in pre-standalone state, doesn't send any flow sync request from that state onwards. And then after that, there is a timeout. Eventually, after which is the the drain timeout, right? Kind of. And then after the pre-standalone.
And this is the Balki, this is the same timeout as the convergence time, you said?
Convergence time is a network level. This thing that might be bigger. This one is like more of a.
This is just to drain any traffic any packets in flight.
Yeah, because you talk about two times. One is basically
this is the control packets in flight. So the first one is the timeout for the network for BGP, for example, for it to converge. And the second one is if there were, like Balki was saying, there's some ACK or something on the wire, we just want to keep it so that.
And how do you determine both those times? How much you have to wait before you say that okay, I'm done, or basically either the traffic has been drained out or the BGP has been converged. Are there certain things you are going to monitor or
config?
So you are not monitoring anything on the network to see that whether or not it has been done.
Yeah, so this is, I think, depending on the network breadth or something. For example, we need some input to say how much is the what is the convergence time for the network, for example. We don't have, it's not we cannot know, we don't attempt to know whether somewhere else the network has converged or not.
Right. Yeah. So based on the deployment, we should keep tuning it, and then we need to configure based on the tuned, value that we see fit for the deployment.
Keeps it simple, but it needs some input from the admin.
Sanjay,
yeah, sorry, I interrupted you. You can complete probably, as your thought on timeout part where you have to wait before the drain, before you have to wait for the traffic to drain, and then what happens?
Hanif, sorry, I have a question before that.
Okay, okay, all right.
So, Valky, I think what you said is once it start getting new flows.
Sorry, Suresh, I have a question even before that. So this a pre-standalone. I cannot find in the HA state machine. Where is it get defined? So it's not even defined in your HA state machine. If you scroll up on your HA state machine, it's not defined there. I cannot find it. And I try to search. It appears that just at the end of the document, there's a pre-standalone state, but there's never been defined what is that state, what is the behavior of the state in the document.
Oh, I see. In the state machine itself. I think that's this thing. I'll add that this thing. Go on.
Okay.
Yeah. So in this thing, right, the compare check start sync. Yeah, I'll add the state there. I think this is the switchover part. So I think that switchover part kind of, it just says there's a switchover, but the state there, the pre-standalone is not. I'll add that state.
Okay. And what is the behavior, right? So we need to define that behavior as well.
Yep. Okay, we'll do. So I think from your go on from your question, right? So in active, I think the same rule that we said, right? When we forward traffic and any state that we get, we will sync it to the standby, to the peer. And in standalone state, we don't sync anything. So that applies to the pre-standalone too. Does it make sense? So in the first half of in the top portion on the left side state machine, till it switches over to pre-standalone, we are syncing state to the peer. Once we move to the standalone, either the pre-standalone or the standalone, we stop syncing state to the peer because we are standalone. We don't have a peer, so to say.
Okay.
Okay, that may be the answer to my question, but let me clarify my questioning. So you were saying that during the transition, once it becomes active and it would start receiving the new flows, it would not sync the flows to the peer for a period of time. And my question is why, right? I think why wouldn't we, regardless, as long as we have a peer, whether the peer is into whatever state it is, as long as an active has a peer, it should sync the state whenever it creates a new state. Why the timeout drain period? I didn't understand that part. Is my question clear, Sanjay? Yeah.
So you're saying from the pre-standalone down, why are we not syncing state? Is that what? No. Before that,
I'm referring to a statement that was made earlier. During the transition, once you start receiving the new flows, it would not sync the flow state to the other side for a certain timeout. Is that true? Did I hear that?
No. I think like we said, during the active, during the initial part, when it is an active, we are still syncing state. Right?
Yes.
Right. We are always syncing state to the peer. And only when we transition to any of the standalone roles is when we stop syncing because we are standalone. The notion is we are standalone, we are not syncing to the peer.
That part is clear. How about the reverse, right? When coming out of standalone to active.
Coming out of standalone to active from, so that will be the peering thing that we did. So we have to go through the peering, do the bulk sync. Once bulk sync is complete, the previous one, two sections above.
Okay. No. That part is fine. Okay, you know what? Let's continue the conversation. Maybe I heard it wrong. Ignore me for a while. I'll come back to this later if there is more questions.
Let me know if it seems doesn't add up. We can bring it up.
Okay.
Yeah. So so just to complete the picture, so this thing happens, and after this, the left side active goes down, comes up, and then we restart the whatever was the flow for the peering, right? So that's the idea.
I have a question about when we start when the two cards are paid for HA and we are trying to bulk sync, there must be a timeout for bulk sync, right? Or not? That is the question. The point here is that if we start to sync just because both have been marked active for certain flows and active for other set of flows, it may not be necessary that they have actually learned the flows, or there may be no flows yet that are learned or inserted. And in that case, what happens? Do we exit the bulk sync?
Yeah.
Or
So
do
you
we
mean
Yeah,
so that will be bulk sync. So what you mean is, let's say there is a whip which is active
yeah,
on one side, but there are no flows really. It's an empty,
right.
nothing. There's been no traffic for that whip yet, or it's not there. There's nothing learned. If that is the case, the active would say it would walk through the flows, find that whatever is there, it would sync. If there is nothing, it would say bulk sync done and move the state machine forward.
I see. And how about the gRPC? How is it handled? Like, suppose if it's even more uneven on each side, like one side is like there are no flows learned yet for those set of flows that it's supposed to be active on, the other side has some flows and it's trying to sync. So is that handled?
So each state machine is independent. It's per whip, like Valky was saying. It's per whip. Yeah.
And the gRPC will remain open. Okay.
Correct.
Okay.
Oh, sorry. Yeah. Maybe a question being asked, right? So, but I couldn't find the description of this pre-standalone, and there is a timeout. I couldn't find the description in the planned switchover section. Why do we have this pre-standalone and a timeout? Maybe that's being
So this is for sure. So I think there is Balki, please extend, as I say, I think query this thing, right? So during this state, till before all the state before this pre-standalone go on, there have been sync packets that are being sent to the peer side, right, to the left side. It might so happen that once we got this, there might still be some packets in there was still active sync going on. So there might be, although we got the message that they switch over to standalone from the left side to the right, there might be some of these control packets that are still in transit. So the second in the pre-standalone timeout is just to drain those control messages from the channel.
Sure.
After that timeout.
What is the control control messages from where to where? I mean, from the SDN controller or from
from the DPU. So for example, one of the examples is, let's say we did receive on the right side, right? We received a new flow and we sent a DPU sync message to the peer, right? Now we are waiting for that ACK to come back to mark it in the flow, right? So we don't need to forward anymore to this thing. So that ACK may come a little late, and that timeout is for because once we get to standalone, we will not be expecting any packets to come from the peer when we are in standalone. So, but there is this window where you might receive because you had already forwarded encapsulated packet to the other side. You're waiting for the ACK to come back from the peer. You need some window so that you can handle those packets, because once you switch over to full standalone, those packets are not legal packets to receive, right? Because we don't this thing. So that just makes that pre-standalone state so that we can drain whatever we had sent just before we switch to standalone. So
basically keep receiving those packets, but not send anymore.
Not send it, exactly.
Are we initiating the bulk sync when we do the planned switchover, or we are not? I saw in that moment, isn't that the standby, the active and standby are in perfect sync?
They are gone. There's no bulk sync involved in this window. It might be, for example, we were doing a DP, let's say a data path sync.
Yeah.
The new flow, which arrived on the right side. We sent the data path sync packet to the left. Now we are waiting for this thing to ACK to come back. Right? If we moved over immediately to standalone, we would drop that ACK. We don't want to do that. So this pre-standalone kind of gives that window where we can still handle those ACKs properly and then switch over to full standalone. But we want to distinguish that state from active because we don't want to be initiating any sync anymore. Right? Whatever was there, we can receive, but any new flows that are coming, we don't want to sync them again to the peer. We don't want to continue syncing them to the peer, but we just want to accept any ACKs that are coming from whatever we had sent from the previous state. So that pre-standalone is that that timeout is for that control plane flush to happen.
I see. So it's mainly like we're not actively sending any sync message to the peer, but we may send those sync message to the peer before. So if ACK comes back, I still honor them.
Correct. We still need to process it. Correct.
Okay. Right. So this is more like a gracefully shutdown kind of thing.
Correct.
Okay.
Do you think maybe instead of calling it pre-standalone, call it something with the word drain in it so that people know what it means without, give it a meaning like that? Is there any kind of a drain connotation with that state?
Sure, I think that we could, no, this thing. And Balki, any?
Just an idea, because then it's kind of self-explanatory. During the question keep coming up.
Yeah, I think wherever we present it to user, maybe we can have some name.
We can have some drain. Yeah.
Just an idea. This discussion is really fascinating, but I keep thinking of a related topic, and that is, let's say we agreed on this and it's all working and people implement on different platforms. How are we going to know it's working like this other than the final outcome? How can we have a high fidelity observation of this thing in action and do test cases and verify that it's behaving the way we expect? And the reason I ask that is because if we just wrote a bunch of code that did all this, we might have a hard time knowing how it's behaving under the hood or doing all this without putting some kinds of, I don't know, maybe generating high fidelity events in a test situation that send out some kind of message that tells us this state's, I'm transitioning to this state, or I'm doing this, or I'm doing that, so that some outside system can observe it behaving the way we expect it. Otherwise, it's kind of like very difficult to know what's going on. Have you guys given that any thought?
So Chris, all these the state transitions, all the messaging is going through the control plane sync channel, right? So if we did monitor and we keep the state machine transitions clean and actually monitor these events that are passing through, would that give enough visibility? I thought the idea was that would give, since it's going through the same control plane sync channel.
I think there is a multiple aspect to the answer to the question, right? So definitely there will be unit tests to test all this state transition, right? So if we are not satisfied that, I think there is this model checking work, which there's a language like TOA plus to fully validate the model, right? So I think we have been, using that, developing the TOA model plus for our Gemini project, which is also, related to the switchover. So we have quite a few experience on that to come up with a formal verification model to verify the state transition. And another question is that maybe we should develop a test to just set up the environment and do continuous switchover and see if there's any traffic drop, right? So because in the planned switchover, I think what I'm hearing is that basically there should be no expected flow drops or anything like that, right? So
yeah, I think those are all good partial answers, but I'm thinking, for example, let's say besides the paper analysis and the let's say there's a static analysis and models and whatnot that verify it and unit tests, but when the system's under load in a real network, in a real situation, and something behaves funny, or we just want to know if it's behaving correctly, even if it looks like it's correct on the outside, it may not be completely correct on the inside. How would we observe that and confirm even under load, full load with lots of corner cases?
So then you do like a stress test, right? So you set up environment and do thousands of tens thousands of switchover and see if there are any packet drops.
Yes, and let's say in the 3000th case there's a packet drop. Would we have enough information to know what happened, why it went wrong in that one instant?
Oh, then we need to failed the test case, and the people need to start investigating why there's a packet drops, right? Those cases.
Right. Would we have enough information to diagnose what happened that one time out of 10,000 after the fact? Because you may not be able to reproduce it. These kinds of things that happen based on.
The idea is to I mean, that's a typical debugging. You have to reproduce it, right? So this is kind of bug. That's a typical debug.
I'm just trying to plant some seeds here that sometimes you can't reproduce it, or you just pray and hope after trying for 3 more weeks it happens one more time. I just want to put that out there, right? That do we have the mechanisms to be able to do it without agony? Right, because these kind of systems are super complex, and you may never actually reproduce it exactly the way it happened the first time. When there's timing and memory and
so there are some visibility. For example, there is flow level information on either DPU. I think the DPUs can maintain flow level information. For example, state, right? Whether what state were we in? Did we receive an ACK back, or where we sent the packet out? So that could help. I mean, postmortem, right? After we see that there is one flow that is failing on the 3000 switchover, something is failing. We know what is the flow that is failing.
Anyway,
like Gohan was saying, could go back to the DPU, check what the flow is. That's typical debugging flow.
Yeah, I just want to put some food for thought out there.
Yeah, that's a good topic, and we should definitely have this discussion in the future. What are the best ways to debug this? Just data traffic, will that be sufficient to determine, if the states are working, and how do we monitor that? That would be great.
I spent 6 months on an HA system before, and so I'm trying to, let's say, leverage that painful experience and just put some bugs in people's ears for now.
Sounds good.
So I mean, Christina is not here, right? So time check. I think
we are at the top of the hour.
So
another time.
I think we clear on the planned switchover. Maybe next time I think we should go over the unplanned switchover again to see, because I still have some questions. How do we measure those traffic disruption? Those kind of things is critical to the to the operation. Can we do that in the next meeting to discuss over the unplanned switchover? Yeah.
Sure, go on. Yeah, sure, definitely.
And also, when I went through the document, I couldn't find too much information on retransmission. So maybe if we can cover some of that next time as well, that would be great.
Retransmission from the DP part, from which one? What were you thinking?
So basically, data path sync, right? For the packets, if we don't have acknowledgements.
I see. I think somewhere this thing you had mentioned, maybe we can talk about it if time is this thing, right? We can go through the path. I think the network itself. So the idea here is because we are not keeping state. If there was a packet that was dropped, there was any network drops, we can probably go over next time and see what happens there.
Okay.
But in general, the idea is the client retransmission covers that too. We can go over that in detail next time.
Okay, that sounds great. We couldn't go over the overlay CMP, how the HA can be, use that design as well. I think next time Gohan and Prince can maybe talk about that. Yeah. Yeah, thank you everyone for joining. Jay, if you could please stop the recording.
Yeah, I'll stop the recording now.
Thank you. Thank you everyone.